Mystery eruption here is a scary observation which is completely true. Despite humans having essentially explored every inch of our planet, we don't actually know which volcanoes produced some of the largest volcanic eruptions in recent history. We have clear-cut evidence that these eruptions did indeed occur via the emplacement of unusually high levels of sulfur and ice cores along with reports of climate variations worldwide. While these can rarely have non-volcanic causes, they are typically caused by very large explosive volcanic eruptions which leave behind massive multimile-wide depressions in the ground known as calderas. So, you would expect the remnants of these recent supermassive eruptions to be super obvious to spot, and yet, more than a half-dozen mystery eruptions dated to the last 2,500 years exist, including 3 dated to the 1800s and 1 dated to the early 1900s. While the vast majority of these catastrophically large eruptions likely originated from known volcanoes that just happen to be understudied, often due to remoteness, what is even more worrying is the possibility that one of these mystery eruptions originated from a volcano still unknown to science, perhaps even hiding in plain sight. For example, we have absolutely no clue what volcano, let alone where in the world the single largest eruption on the planet occurred from during the last 2,500 years from some volcano in 426 BCE. Well, the good news is that through fieldwork and the hard work of a multitude of scientists that one of the many recent mystery eruptions is mystery no more. New research has discovered 1831 eruption affects the volcano responsible for a mystery eruption in 1831 which ejected so much sulfur dioxide into the atmosphere that it blocked a portion of sunlight, thus cooling worldwide temperatures, which in turn caused crop failures linked to famines that may have killed more than 100,000 people. The volcano in question was determined to be Russia's Zavoritsky caldera, which is located Zavoritsky caldera on the presently uninhabited Simashir Island within the Kuril Island chain. The eruption in question erupted so much magma from its magma chamber that it created a large void space which caused overlying ground to collapse downwards like a sinkhole, forming a 3.5 kilometer or 2.2 mile wide caldera. This caldera removed the 2,400-foot high peak that likely existed within its northern half, with the bottom of the 430-meter or 1,411-foot deep depression in the ground filling with a lake that has since been partially filled in by eruptive products of more recent eruptions. Based on my own personal estimations, I suggest that between 5.44 and 6.72 cubic kilometers of eruption-sized tephra was erupted, meaning the eruption in question was approximately 5 times larger than the 1980 eruption of Mount St. Helens, rating on the Volcanic Explosivity Index as a 5. Core samples taken from several of the region's islands as noted in this scientific paper being shown on screen suggests that the amount of primarily dacite ash which fell from this major eruption likely accumulated to more than 4 meters or 13 feet thick in some areas. However, criticism, analysis of data. While the work of these scientists is exemplary, I have a criticism of their model which when totaled suggests a significantly smaller volume of tephra was ejected by this major 1831 eruption than would be expected based solely on ice core data. My criticism is that core samples were only taken on actual landmasses which are pretty sparse in the Kuril Island chain, and I believe this limited dataset is making it incorrectly appear that the eruption plume center drifted perfectly towards the center of other landmasses in the same island chain. This is just statistically improbable. Don't get me wrong, their data could be correct, but I think several submarine core samples are needed further to the west and east of the eruption site and the existing islands so a better estimation of the eruption's total output can be more accurately determined. I personally think that the vast majority of ash from this eruption fell into the sea via what could have been a prevailing wind that had both a weak southwestern and strong west-northwest component to it depending on the specific altitude the ash was ejected to. This would be more plausible in my opinion based on prevailing wind directions during the summer when the eruption occurred. Since we now know the age of two middle caldera of its Zavoritsky's calderas, including the supermassive VEI-7 eruption it produced 20,000 years ago, I suggest that we now try and determine the age of its middle 6-kilometer-wide caldera. As a final note, I would like to thank my new patron David Barker for supporting